for the convergence, I believe you can run the same model twice and you won't get exactly the same thing. You guys are creating it a little different than me, maybe a different line first than another, or creating a different surface first than the other. I can't entirely, I know this is definitely different. There's something much different on mine than some of yours that I saw. The idea is if you trimmed out for now, you're good. That means the model is working. There's most likely an issue with your weight, or there may be another issue with surfaces itself, which I'm going to ask Goodmanson myself to see if he knows anything about it and show him exactly what happened. For now, take what you have and just, for at least our stuff, assume it's correct. When it comes to your models, just be very careful on what you're doing. There easily could have been an issue with me transferring the file from one location to another. I actually just transferred it from 2 locations today. I saved it accidentally in a different location. So I copied it to my P drive, and then I copied from my P drive to the shared drive. A lot of issues could have happened along the way. I really don't know. On the older versions, I never had an issue with this. So that's what makes me believe it's the version, not anything you guys did particularly.
Yeah, sort of inertial, we have a couple different inertial parameters.
What was that?
We have a couple different inertial parameters, like my CG is 2 feet off of yours.
Okay.
I don't have an IY.
And that's, honestly, that's really odd to me, because we've all been, I'm sure you guys have been following really well.
It's the same thing, so I don't know.
Yeah.
Why, if you analyze it again, it turns out to be like a little different? Oh,
Because-
way different, actually.
Way different, or
Well,
a little bit different? So
The graph is way different. The numbers are kind of similar.
So graph will be different because the numerical method does not necessarily need to be the same each time. In terms of numerical methods, you have an initial condition. The way it calculates the initial condition can vary each time you run it. So, and then that perpetuates to the next decision of what it's going to do. So let me go back to my table real quick. So I started here, and it said, okay, we don't have enough elevator deflection, so let's add a little more, and we increased the lift. Now the moment increased. Did it one more time. We changed we probably changed the deflection in some way, but now our lift decreased, our moment increased, and then we have a huge flip in reversal. So it's changing not only AOA, but elevator. So that's why we have these huge changes. So it has 2 parameters you can change, and how it does that, I have no idea how it selects. Okay, if you've ever created like just a numerical method for convection diffusion flow in 1D, you have an initial condition, and you just say you have a different convergence criteria. After every iteration, you can increase or decrease by an average, or a specific amount, or some random number between this criteria. So a lot of different factors. The graphs are not as important. What is important is the final result. Okay. So if you can converge within 30 iterations, that's a maximum I would say you guys have to really run is 30. I probably would run 20 on average. If you can converge in 30, then you're good. If you don't converge under 30, then there's maybe something wrong with your model. Could be something wrong with surfaces. Okay. One more. We're almost there. So again, we did everything, and so if you close, and we can close this real quick. Let me go to my view. If you go to your 3D view and look at your tail, notice that your elevator is now deflected to the trim state. Okay? And if you go over to your blue table and scroll down to, where is it? Flight conditions, your AOA is different. It's not 0 anymore. It's whatever we had the trim convergence calculated. All right? So last thing we need to do is task and determine stability derivatives. So we're going to get all of our parameters in terms of CM alpha, CM delta E, CN beta, CM, or CN beta, CN delta A, delta R, CNP-R, CNQ-R, all of those, okay? And right now, a lot of those might mean not much to you, especially the roll rate parameters, unless you've taken dynamic stability and control. And next time, I'm going to talk a little bit more about that, because the next class, the last class next week is going to be all stability stuff, and making sure everything's nice and pretty, okay? So, determine stability derivatives. We have to tell surfaces what to determine. We want to do angle of attack, angle of yaw, roll, pitch, yaw, roll control derivatives, which are ailerons. Click setup, and you have to tell surfaces which surfaces to use for the deflections. So controls deflected down are going to be let me read this again. Left aileron down, right aileron up. So that's why we name them. At the top note, left aileron down, here, down, left aileron, right aileron, or up, right aileron. Okay. You can close. You guys got that?
Yes.
Okay. Close. That was never on the old versions, by the way. You always had to think about what to deflect, and I almost always got it wrong. So if you have a pitch control derivative set up, same thing. You're going to do positive down. It's going to be both the left and the right. So positive down deflection would be left and right. Close. Let me double check that real quick. Yeah. And then yaw control, same thing. Controls deflect left for positive or right for positive, and then we're going to click right for positive. Thank you. Oh, I have to leave that on. Yeah.
Right.
Alright. Yep. So, you guys verified. I trust you. So, I'll go through that real quick again. Roll control. It says at the top, left aileron down, right aileron up produces a positive rolling moment. Then you're going to do left aileron, right aileron.
Oh, yeah, I think the yaw's backwards.
Okay, I'll check that out again in a second. So pitch down. If you take our axis, we want a positive pitching moment. So yep, this one's wrong too. Sorry, hold on. So if you want a positive pitching moment, which would be, no, that's right. I keep forgetting their axis system is a little off.
Yeah.
So this is right. If you deflect your elevator down, you're now going to pitch your aircraft down. So now it's,
Isn't that a negative?
yeah, it is. So it is opposite.